I'm James Brierton. It's Wednesday, February 1st, 2023. This week, on an all-new edition of the Carolina Weather Group, we will take you to Greenville-Spartanburg, the home of the National Weather Service, where the long-awaited radar repairs are underway. Our guest this week, WCNC Charlotte Chief Meteorologist Brad Panovich, will debunk the myth on whether or not thunderstorms in winter means that snow is on the way. And we'll catch up with Steven Jaume, an associate professor at the College of Charleston, who's going to explain and provide some new insights into why South Carolina keeps seeing so many darn earthquakes. It's going to be a good show. Buckle up. Here we go. And we start on this February 1st with a live look at the clouds and the breezy conditions this evening at Clemson University, courtesy of WeatherStem. I'm James Brierton in Charlotte. Welcome to an all-new edition of the Carolina Weather Group. If you're joining us live on Facebook or YouTube, please use the live chat to chime in. And if you're watching the replay later on, you're still welcome to join the conversation. We always check those comments after the fact. Joining us on our Carolina Weather Group panel, we have Frank Strait in Columbia. We've got Scotty Powell in Myrtle Beach. And as mentioned, Chief Meteorologist from WCNC Charlotte Television, Brad Panovich, is back with us, fresh off his trip from Tahoe. Looks well rested. Did you see any snow this past weekend in Winterfest? You kind of boomeranged all around the country there for a moment.
Yeah, I went from West Coast mountains to East Coast mountains. Winterfest, not a ton of snow. There was a little bit on the ground, nothing like last year when it was so cold. They actually canceled the polar plunge, believe it or not. It became a safety issue. But I will tell you, having been there for the last, I think, 4 or 5 years, probably the most attended Winterfest I'd ever seen in Blowing Rock. The town was absolutely packed, and I think it was because the weather was actually pretty nice, and people took an opportunity to head up to the mountains. So it was a great weekend. I always love Winterfest because celebrating winter weather in North Carolina mountains is always a good time.
It is, and that's one of the few places that has actually seen snow. We'll talk more about that coming up ahead. Plenty of thunderstorms, not enough snow. A shout out this week to all of our supporters at patreon.com/Carolina Weather Group, where for just $1, you can unlock extras and see early access to select episodes. Or in this case, since we're live this week and I don't have a time machine and can't get you early access to a live show, we sent you early access to our first story, which takes us to Greenville-Spartanburg, the home of the National Weather Service, serving upstate South Carolina, western North Carolina, including the cities of Asheville, Greenville, Spartanburg, and even all the way back here to Charlotte. As you may remember, the radar went down on December 31st, way back last year, and has been out now for more than a month and counting. Well, some good news finally arrived last week. Repairs are underway to return that radar to service. Here's a look at how all that played out last Friday at the National Weather Service office there in Greer. The day has finally arrived. Radar repairs getting underway here at GSP. For the first time in nearly 3 decades, a crane is removing that big golf ball thing, that's called a radome, to expose parts of the radar underneath. They need to remove a 27,000-pound pedestal that supports and spins the radar, and all of that is being spun by a bull gear, which failed at the very end of December, which has prevented this radar from observing weather in the Carolinas for the past couple of weeks. Right at sunrise and without delay, the crane shoots up into the sky. Anxious crews begin repairs at the GSP radar site. Today, a choreographed dance in 4 major stages. The dome comes down, the old pedestal is removed, the new pedestal is installed, and the dome returns atop the tower. All of it could only happen if the winds stay calm enough. Right now, at 8 a.m., a truck carrying the radar's new pedestal gets into position. Crews secure it to the crane, and the new pedestal is brought to the ground and turned upright. At 9 a.m., crews get into position atop the radar tower. With nothing but skill and safety lines between them and the ground, these men are working to secure straps around a 30-year-old radome that stubbornly sits atop a tower. Not only do bolts hold it into place, but so does dirt and rust. The radome will not only be lifted, but it will be cut away from its dependent tower. They work with precision as the rest of us look on in awe, and after another 30 minutes, the moment arrives. The sun shining on the old pedestal for the first time since the 1990s as the radome is hoisted up and over the National Weather Service office. You've heard of solar and lunar eclipses, but here, a radome eclipse in the parking lot of the National Weather Service as the radome comes down to the ground. Now the target, clear as day, sights set on the mobilized pedestal. A little after 10 a.m., straps are secured, and up and away it goes, the crane operator making this look easy as he swings it out and around in front of the watchful crowd. Down it goes ahead of a long truck ride back to a refurbishment facility. Now the tower sits empty, a kind of haunting view. Its radar dish laying flat, out of view from the ground, but still safely atop the tower. At 11 a.m., work begins preparing the new pedestal for flight. It must be secured vertically so that it can be cleanly lifted away without swinging into any other objects. The task is not as easy as it sounds. More than an hour expires before liftoff. Under the watchful eyes of high noon and despite increasing winds, the new pedestal is lifted into place. It's the moment we've all been waiting for. Onto the radar site here at the National Weather Service in Greenville-Spartanburg. That is this white object right about here. It will eventually hold the radar equipment that scans the skies, spinning around 360 degrees, 365 days a year. As you might remember, the radar site here at the National Weather Service office in Greenville-Spartanburg stopped working at the end of December. That's because a bowl gear inside the old pedestal had given way. That was the gear that spun the equipment around, and after 27 years of turning, it was no more. That's right, because this radar has not been taken apart since it was first installed. That was the original bowl gear that failed. A new bowl gear inside this new pedestal will continue to serve the Western Carolinas and upstate South Carolina through 2035 and beyond, or so the federal government hopes. That's all part of the Service Life Extension Program. That's actually what you're seeing going on behind me here, because when the radar failed, the timing was not great, but not all too bad, because for the first 6 months of 2023, the National Weather Service was already planning to replace all of the pedestals and all of their radars across the Carolinas. So when this one gave way a little bit early, they called up the National Weather Service in Columbia and they agreed to switch places. So the Weather Service hopes to have this radar back online very soon, and then we'll travel site to site across the Carolinas one by one, intentionally taking those radars offline for a span of 1 to 2 weeks in order to repeat the work you see behind me. So if you want to go check it out, keep in touch with your local National Weather Service office, and you might get to see them take the radome off. That's that big golf ball looking thing that doesn't come off very often. At the National Weather Service in Greer, I'm James Brierton for the Carolina Weather. So it was a really cool experience. As you could see, that was a not made for TV package. That was way too long to air on television, but I wanted to take you guys along for what turned out to be a 6 or 7 hour long process there at the National Weather Service. My dad and I got up at 5 a.m. last Friday and drove down there. And a couple things that I wanted to share with you all that did not even have time to fit into that narrative. So when we got there at 7 a.m., it was 28 degrees. And I took my camera out and I put it on the tripod. And I zoomed into the radome. And then I went to zoom back out and the picture would not come back out. And then my camera made this horrible grinding sound and then just died for the rest of the day. I am 2 hours from home and I have no camera, which is not entirely true because we all have cameras in our pockets. So that entire story was shot on my cell phone.
It's a good thing that cell phone cameras are really good these days.
Well, and that's the funny part is probably my phone shoots 4K. My video camera that I'm talking to you on right now, spoiler alert, it came back to life, does not. So it ended up being a higher resolution package, which is why we released it to our Patreon supporters in 4K, because I was like, what do I do with this? There you go. Thank you, Patreon supporters. Another thing, and I mentioned it a little bit in the story, the winds are no joke. They actually delayed it a day initially because of the winds. And then as we were getting into the afternoon hours, as they were trying to get the radome back on, the winds were picking up again. And you can see it. It's just dangling from a crane. And now they're trying to lower it back down on the tower. Thankfully, they were able to do that. No one got hurt. And now the technicians from the Weather Service are in there doing the calibrations. And I think it could be any day now that we get our first pictures back from GSP.
I think it'll be a random day where we'll see the radar pop up and like, hey, it's back.
Yeah. And a huge shout out to Frank, the National Weather Service in your neck of the woods in Columbia, because they agreed to switch places. So all of the radars throughout the Carolinas are going to get their service life extension program work done, where they're all going to get these new pedestals. And Columbia switched places because of the unforeseen repair. So we talked to Tricia Palmer from the National Weather Service in Greenville-Spartanburg, who alludes to just how close this radar made it nearly 3 decades later and then died just short of the finish line.
So to lose a radar, what happened with our radar at the end of December is we lost the main gear that turns the radar. It was going to be replaced with this program anyway, with this refurbishment. And so we just needed it to hold out a little bit longer, but it failed. Just like I said, car parts, when you have gears that fail in your car or a transmission that fails. So it was going to be replaced anyway, but it failed at the end of December. So the radar has been down since then, and here we are at the end of January. So we've had our radar down for almost a month. So to lose the main radar for the Western Carolinas and Northeast Georgia has been a bit of an issue for us. We've had a couple of severe weather events. So what our meteorologists do when we lose the radar, we use what we actually have a name for it. We use a total observation concept, and we supplement with other radars. In our case, we might use the radar in Raleigh, North Carolina, Morristown, Tennessee. Primarily, we'll use the Columbia, South Carolina radar. Also in the Charlotte area, and we use this all the time, there's a radar at the Charlotte airport, and we use it all the time during severe weather events anyway. So we use that heavily to supplement our data in that area. But there's other means of supplementing data. For example, every night we lose our visible satellite imagery. So when we're looking at fog, we have to use other means of fog detection overnight. Ground surface observations. We have other ways to view fog in the overnight hours. So our meteorologists are capable and well trained in using supplemental data to help to try to figure out what's going on when we lose one source of observations.
So Brad, let's bring you in here because she alludes to a couple of these severe weather events we've had, particularly in January. Last January was all about snow. This January is all about thunderstorms. So what happens? Explain this to us, because I think some people are going, I still see rain on TV. I still see radar in my app. So what are we missing here?
You know, what we're missing is the higher resolution, low level slices of the radar, what you're seeing on your app. And you might even notice some degradation of that radar ability as well. That's called composite radar. It's taking all of the radars and kind of splicing them together. But when a radar like GSP is down over the Western Carolinas, the radars that are covering it are from the surrounding areas: Atlanta, Morristown, Blacksburg, Raleigh, and Columbia. Going into that composite slice. And what you're getting are some mid and upper level slices. So you're seeing radar returns. Some of that might not be reaching the ground, and it's usually going to be returns from 5, 10, 15, 20,000 feet. So if there's not moisture up there, there's nothing that's going to show up on that composite radar. But you're going to get something that will fill that area as well with the radar. The real key part is the low level reconnaissance, we call it, the low-level remote sensing. Anything below about 5,000 feet you lose with not having that radar up. And that really becomes problematic in severe weather events like we saw several of. I mean, to give huge kudos to the Weather Service. They did a great job using other means. And, you know, Trish was alluding to this. One of the ways that we supplement data is with human beings, spotters. Mm-hmm. Spotters become really, really important. Thank goodness for GOES 16 and GOES 17 data. The sensors on those can really supplement a lot of data. You know, you're getting 30-second to 1 minute, picture updates from those satellites now, which in some cases is more frequent than the radar slices. So there's a lot of ways to supplement it. It's not the greatest thing, and any meteorologist will tell you the more data, the better. But you're going to make do with what you have. And if you're going to have a radar go down, you know, January is probably a good time because typically, I'm knocking on wood here, we don't see severe weather in January. We did this year, But that's typically a time of year you wouldn't be as reliant on it for severe weather. Because let's be honest, the radar is really something for severe weather, what we call mesoscale meteorology. Severe thunderstorms, tornadoes, flooding, hail. That's where that radar becomes really, really important.
Yeah, let me pop this up again. This is the map that the National Weather Service put out as alternative radar. So it's missing the one that would be there in Greer, in the Greenville area. And you can see Morristown is in green to the north, Columbia is in red to the south, Peachtree City near Atlanta is purple to the south and to the west, and then Raleigh in yellow to the east, and blue finishing out with Blacksburg. You know, I think you hit it on the nail on the head. I think Tricia mentioned it, and we also have a live comment from NCTN High Country Weather, who's watching tonight on YouTube. He says, "I can't wait to get the radar back, especially for those border areas with northwest flow, because when you look at this map, it's a map with perfect circles. Like somebody just drew it with a compass, and it's great, but it doesn't take into consideration the terrain and the things that actually in reality get in the way of the radar." So there's an example of that here we found. If you're looking at radar scope, and we kind of tried to draw it in a line here. It's not perfect. There is some data there, but essentially you can kind of see how heavy rains just north of Greenville almost look like they're coming out of nowhere, just south of where it says Hendersonville. And it's because the beam blockage. Tennessee can't see Highlands or can't see north of Clemson until that heavy rain gets far enough to the west that the radar in Columbia is picking it up. And that's just a kind of an example, not to call anybody out, but we're trying to show really the value of the whole network when it's working.
Yeah, there's a lot of blockage for topography. And you actually saw it on the Morristown radar there. You could actually see the Smokies showing up on the radar because the beam, if you look up there, east of Pigeon Forge, those aren't radar returns. That's actually the radar bouncing off the Smoky Mountains. So you're seeing the intersection of the low level slices, what we call a volume scan, the 0.2, 0.5, even a 1 degree, probably running into Mount LeConte. And a couple other mountains over there. And it kind of blocks the view looking down into the upstate. So yeah, the thing about the earth is curved. So when the radar beam goes out, the radar gets farther and farther away from the ground as you get distance away from the radar, but also things block it. I mean, we learned out in Wilmington, they had to move their radar because it was blocked by trees, believe it or not. And they couldn't cut down the trees. They actually moved the whole radar. Some parts of the country, buildings and water towers and communication towers, the terminal Doppler radar at the airport that Trish alluded to that we use actually has a huge beam blockage in the northwest corridor because there's a communication tower there that they actually block the signal so it doesn't interfere with it. So radars have, they're not perfect. They have fallacies. I think that's the thing we take for granted because everyone pulls up their phone and, there's universal radar coverage. Well, it's not really the way it works. There's big breaks in it.
Yes, exactly. And so we did also pose this question to Tricia and ask kind of how to compensate for these things. And here's the answer she gave us with regards to the beam blockage.
Are there any areas that, given the network and the layout, that like GSP exclusively sees or really ideally sees that you'll be most grateful to be able to get that?
Oh, sure. Here near our office, here in the upstate, here in the mountains. Especially when you get into just to our north, because without our radar, western North Carolina, outside of the range of the TDWR, you can't really see that very well with the Morristown radar because of the beam blockage. It's too far away from Raleigh. It's too far away from Blacksburg, especially up I-26 towards the Asheville area. The Smokies really block the radar from the Morristown radar. So we are looking forward to getting our radar back for that. But luckily it's January. Severe weather is, climatologically, it's unlikely to get severe weather in that part of the country. So what we were worried about is if we had like a shallow freezing rain event and we couldn't see it. But again, that's where citizen scientists come really into play. And we have been very fortunate to have a lot of help from the residents across the area sending in reports.
And that's where Storm Spotter is at home. We've done it the last 2 years here at the Carolina Weather Group with the National Weather Service in Columbia during that Storm Spotter training. Really, I mean, even when all the radars are working, the eyes on the ground are so helpful.
Yeah, absolutely. I mean, I'm a big proponent. I love the technology. I want as much radar data, satellite data, mesonets, but I'm telling you what, good trained spotters are worth their weight in gold because they're telling you what's actually happening. Remote sensing is kind of giving you an idea, but you really can't tell. That's why cameras, and James, you know about that. We love our camera network. We're trying to build it out. And spotters and chasers, they do serve a really vital resource to us to get us, information of what's happening below the radar beam. And oftentimes that will be a huge, huge asset. Yeah, I love that.
Here's the look at the WCNC tower camera, Dallas, North Carolina. This
that
was
was
a
the night
January snowstorm, right?
That was the night of the tornado in Gaston County.
Yeah. Great vantage point. And
which I got to give a huge shout out to the Weather Service because that was the one tornado warning and it verified. And that's pretty incredible without having the GSP radar. The terminal Doppler was a huge asset. But one of the things about the terminal Doppler radar, it's a much weaker radar. It's C-band and it has fewer products. It doesn't have dual polarization products, which would allow you to see tornado debris signatures. So to use it for basically detecting the couplet and seeing the reflectivity and relying on some really good spotters in Gaston County, that really was a remarkable warning and verification there without the radar.
Yes, I'm very grateful that we had the terminal radar that night. Otherwise, I think things would have been dicey. Now, the enhancements on the radar, the refurbishment of the pedestal is actually going to be happening at all of the radar sites across the Carolinas. Each one of these visits takes roughly, and we're rounding, about $1 million in order to keep this technology online. It was developed in the 80s, deployed in the 90s, being refurbished now in 2020-ish, and then they want to keep it going for another 15 years or so. Greer is being calibrated. Columbia is next. Wilmington is done. So let me read this comment and bring Scotty Powell in. Jeremy, watching on YouTube, says we need to get something done with the radar out of Wilmington because, as Brad alluded to, the pine trees there have long kind of been a hindrance. Scotty, you said something to me on the phone the other day that I feel like is relevant here.
Yeah, so I don't know what happened. I don't know if they moved the radar or if they decided it was easier to chop down the trees, but we have full coverage now along the Grand Strand. That wasn't the case a couple months ago. So I'm not sure what's happened up there. We need to really investigate what truly has happened because I don't think you can move a radar sat that quickly, but somehow something has happened and we have full coverage now on the Grand Strand, which was not the case just a couple months ago. So that so far has been a good thing. So we'll see how it goes. Yeah, fingers crossed. The same time that GSP was out with their service life extension program, so was Wilmington. So I believe the meaning was they wanted to get this knocked out pretty quickly before hurricane season started because obviously Wilmington, Charleston, Morehead City, they all use those radars very frequently during the tropical season. So right now, fingers crossed, the radar is doing pretty well here along the Grand Strand down in or up into Wilmington. So we'll see how that lasts. So yeah.
Greer is also surrounded by pine trees. I stood there for several hours just kind of taking in the scenes, and I was like, oh, now I get it. Now I see where this. I was like, I give it a decade. How fast do pine trees grow?
Yeah, yeah. I meant to reach out to Stephen Paff. He's
find out.
He's the same as Trish is and GSP to kind of figure out what's happened there. So we'll investigate that and we'll try to get some answers for you. But for right now, the Wilmington radar is showing the Grand Strand, and that is much needed. So we'll hope it sticks around.
Well, subscribe to the Carolina Weather Group wherever you get your audio podcasts on YouTube, because we have another show about the Service Life Extension Project, talking with the National Weather Service, the headquarters, the folks who run this entire program, coming your way in a few weeks right here on the Carolina Weather Group feed. You're not going to want to miss it. Don't go far. We're going to take a short break. When we come back, Brad Panovich is going to let us know why all these thunderstorm events we've been having here in the Carolinas does not mean we're going to get snow.
And let you guys see what it is that I'm experiencing.
Trying to get a direct measurement with a handheld Kestrel anemometer here. We'll see what we can pick up, but And there goes change.
When a tornado-warned cell came through the neighborhood and it brought down several large pines, just like the one you're seeing right here behind me. To give you a sense of what the aftermath of storm damage smells like, it smells very heavily of pine and also sounds like chainsaws. We have another tree down here. This one just barely missing this brick home.
Down here. I mean, this is incredible. Let me turn the camera around. Get us back into kind of a dry view.
And I get up here, and all of a sudden, the storm surge started. And all of a sudden, I ended up in about 4 feet of water.
I'm Scotty Powell here reporting just outside of Sparta, North Carolina, where you've seen a lot of the earthquake damage. Again, a 5.1 magnitude earthquake rocked Sparta, North Carolina earlier this morning, just after 8 a.m.
If you go look at the footing of that, you'll see where it was a twist. Very severe wind that caused these structures.
From Gaston County to back here in Mecklenburg County, those were just 2 of the tornado warnings that were issued here for the greater Charlotte area.
I'm not one for hyperbole, but it's countless at this point. There's trees on houses, there's a lot of roads that are blocked. We're just trying to get cleaned up so people can get through.
Have you ever seen the Dan River like this before?
No, not that I can recall. I mean, I've seen it fairly flooded before, but I've never seen it to where we're now kind of asking ourselves, okay, a couple more feet and it might get over those bridges.
Welcome back to the Carolina Weather Group. It's February 1st, 2023. We're here with Frank Strait and Scotty Powell. And then Brad Panovich from WCNC in Charlotte is the chief meteorologist and also the man who helps you better understand the atmosphere around you in their reoccurring Weather IQ segment. And kind of a crossover, Brad, with the station's Verify fact-finding initiative. You did a story earlier in January because if I were to spin my hat around and put my WCNC hat on, I know we were getting lots of questions at work from people who were like, hey, we're getting all of these thunderstorms. Does that mean it's going to snow in 10 days?
Yeah, and so this appears to be a southern thing, and it really in the Carolinas. And I know Frank could probably allude to this more. It's something I've heard the 20 years I've been in the Carolinas, and it seems to stem from a lot of folks' grandparents. It seems to be a grandma and grandpa type thing, that there was this old wives' tale that if there was thunder in the winter, within 10 days, you were going to get snow. Now, I love these kind of old wives' tales. I like kind of looking at them and how they came to be. Most of them are myths. I'll be honest with you. Most are myths, but some had a basis of truth to them because, they didn't come out of thin air, right? And if you think about cold fronts in the wintertime, we go from warm to cold. There's usually going to be thunderstorms. So the one thing you typically see when you see thunder in the winter, it's going to get cold. But as you know, as a snow lover, as I am, we get cold. We don't get the moisture and the cold to work together all the time. And it's not always within 10 days. And so I went back and I looked at the data as far back as I could. And I actually started doing this a couple of years ago. I should keep a database. I went back to the winter of 2011 and 12, all the way through this winter. And I came up with like 76 or 77. I have to look back in January, make sure I count them all. 77 instances of thunder in the winter months, December, January, February. And like only 8 times did it snow within 10 days. So that's a really poor correlation. You'd want to see that correlation be at least like a 2-to-1 relationship. That's like a 10-to-1, 11-to-1, 12-to-1 relationship. So there's really no correlation to it at all. It's pretty random. In fact, one cool stat I pulled out when looking at this, it's more likely to snow within 10 days of a day of 60 degrees than it is of thunder, which is kind of interesting because, 60-degree weather is probably a little more frequent. But it is a myth, but it is something that was stemmed on, I think, on people's observation bias of a big cold front coming through and it getting cold. And maybe 1 out of 10 times it worked. And so you only remember that one time and you forget the 9 times that it didn't work out. And that happens quite a bit in meteorology. People tend to only remember the times these myths work out and they forget all the times it doesn't. Like I always joke, it's like the Ron Burgundy quote, 60% of the time it works all the time. It's like it's just one of those things.
Right. And just look to this winter. I mean, think about how many thunderstorms you've seen. And if you're not in the mountains, you haven't seen any snow this winter.
Yeah, this winter is a prime example because we're getting really close to maybe having a snowless winter in
Right.
Charlotte, which would be an
How dare you say it out loud?
Well, it's February 1st as we're doing this. We're recording this, right? We do have the snowiest month from a percentage standpoint and the snowiest calendar day, March 2nd, still ahead of us. But this, I think I looked, this is like only the 31st time that we've gone this far into the winter without even a trace. So we're getting into some rare air, 68 days now, I believe, as of today, with no snow at all in Charlotte. So we're getting to that time where you start looking at that. But it's one of my favorite facts about Charlotte weather. I mean, for a city that only averages 3.5 inches of snow per year, we've never had a year with zero snow. That's 145 years of record keeping. Right. That's just an amazing stat to me that's true. Now, 11 of those times it was a trace, but still, that's only 11 out of 145. We've always had at least measurable snow in those other winters, which is pretty crazy for a city that, doesn't see that much snow, but we always get that one. I remember the one year, I think it was 2014, maybe it was 2015, 16. We were going, it was like this year, James, and we went through February, we went through March, and I'm like, oh, this is a year, crazy upper low on April 2nd. We got snow on April 2nd of all days, like 2 inches of snow, wet, heavy snow under one of those upper lows. And on a Sunday morning, everything was blanketed with snow. And by noon, it was all melted. But it kept the streak going, and it didn't happen until April of that season.
That was the storm that we had pollen mixed in with the snow. If
Yes,
I'm not mistaken. We had like
we actually had yellow snow.
Yes.
Different kind of yellow snow. I don't know which one's worse. The pollen snow is pretty bad too.
Yeah.
Well, I'll take that because that's the snow pulling the pollen out of the air, so it cleans the air out.
That is so true, Frank. I mean, that's the thing. Pollen is, is always in the air. Snow is like nature's vacuum cleaner. It will remove everything. And yeah, there was a lot of pollen in that snow. It was crazy when it did melt. There was big piles of pollen all over the place. So, yeah, it's one of my favorite myths too, because people always say that, the thunder and snow thing. I think it just gives people hope. I'm always someone who loves to talk about anything that gives you hope for some snow. But from a scientific standpoint, I always like to look at the data. I'm one of those people. We all have biases. We have certain things that we're biased about. I always like to let the numbers and the data speak for itself. And so when you look at the numbers, it's like, okay, I'm crazy. This doesn't really work out.
Well, let's go ahead and look at the numbers and also keep a close eye out. Your expert in this package looks very familiar.
Oh, yeah.
We've seen thunderstorms many times this winter so far, and that's renewed the common question about thunderstorm and snow. This is the question we often get.
Hi. We're students from the Goddard School in Matthews, and we were just wondering if it's going to snow 10 days after thunder in the winter.
So let's verify. Does thunder in the winter mean snow is going to fall within 10 days? Our sources begin with Frank Straight. He's the severe weather liaison for the South Carolina Department of Natural Resources. We're also going to consult weather data from the National Weather Service. Official weather observations in Charlotte are recorded by the National Weather Service using equipment over at Charlotte Douglas International Airport.
I remember my grandmother saying when I was like 4 or 5, when we'd have a thunderstorm in winter, she'd say, oh, that means it's going to snow within 10 days.
Data shows exactly how often this myth does happen to work out. Since 2011, weather observations at Charlotte Douglas International during the winter months show 72 days with thunder. Snow fell only 8 times within 10 days. That only comes out to just 11% of the time.
When you get a thunderstorm in the wintertime, it's usually because of a big change in the weather pattern, or oftentimes because of a big change in the weather pattern.
As you can see, oftentimes when we get strong cold fronts, there's thunderstorms and warm air on the front side, and occasionally there's cold enough air on the backside for snow, but oftentimes it's just cold. The snow, if it does happen, it's just a happy accident.
It's an old wives' tale, but even though there is sometimes a reason why it works out, it just doesn't happen often enough.
So we can verify that no, it doesn't always snow after thunderstorms in the winter. With your Verify, I'm Chief Meteorologist Brad Panovich.
That's a really smart expert you found for that story.
I know.
That guy needed a haircut.
Those guys look familiar.
I know. Look, That is one of my favorite snow myths, but I don't know if you guys have heard this one, and I heard it a lot since I've been here, is if snow lies on the ground for 3 days, it's waiting for more. Have you ever heard that one?
I
Yeah,
have.
I've heard that too. And down here, I think it's complete nonsense.
Yeah, it doesn't work out as well. But that one also has a little kind of grain of truth, because you think if snow here melts literally the day after it falls.
Right.
But if it lays on the ground for 3 days, it usually means there's a prolonged cold snap. And at least you would have the opportunity for snow at some point in the future. But it doesn't work out all the time around here, because
well, the one example that I saw when I was a kid of seeing snow lay on the ground here in the Carolinas for more than 3 days would have been the 1988 storm. Where we had snow on the ground for 10 days in Charlotte, if I remember correctly. And it wasn't waiting for more. We didn't get any more snow. That was the only snow event that winter, yet perfect example. It only takes one storm to get you above normal snow. We got a foot of snow in Charlotte from that storm.
Yeah.
And
I think it was the 2013-14 year where we had a light snow, but it was that really cold January. When I was looking at the January stats, I'd forgot about this winter. And I think it was 2013 or 14 January, where the average temperature in January that year was 35 degrees in Charlotte. It was a really cold January. And I remember it may not have been on the ground for 3 days, but there was snow in the shade for like a week. I mean, it was pretty crazy how long that snow stuck around. But yeah, I think you're right, Frank. Usually, like in '88, if I'm not mistaken, that was that big storm, and then we got the Arctic high came in.
Correct.
So it was frigid for the next week, but it was Arctic high pressure, so it was super dry and cold, and everything was a deep freeze. So it kind of just sat there, but no more snow was coming.
Right. There actually was another snowstorm along the coast. I remember the PD had like a 3 to 6 inch snowstorm about 10 days after the January '88 storm. But I don't remember if they had any snow from that one or not down there. So I'm not sure. And if they did it even last that long?
Yeah, it's my class tomorrow. We're going to be talking about snow communication. And one of the things I love about snow is it just, like these myths and these stories, it just elicits certain feelings and emotions and memories in people. Snow, of all the weather phenomena, I don't know what it is about snow, especially in the Carolinas, it just makes people freak out. And I think the memories of it is just very skewed. My parents always had told me they walked uphill in 2 feet of snow to school, and you hear those stories, but I think they're like fishtails. You remember things a lot differently as you get older, and you realize,
and
there's
some
no
of these
data to support that.
Yeah, and some of these stories were developed in the days when weather forecasting was more an art than a science.
Yeah.
So I mean, take for example the 1973 snowstorm that Melissa and I will be talking about sometime soon, and that storm, it was it wasn't forecast at all. I mean, they were forecasting cloudy, chilly weather the day before that storm when we had 2 feet of snow in Rimini, South Carolina.
Yeah, snowstorms used to sneak up on you back then. Now it's like there's more fake storms than there are real storms, because you talk about every tiny chance. It's like hurricanes, nothing sneaks up on us anymore. And you hear a lot of stories about that, like, oh yeah, they were forecasting a few flurries and we got 2 feet. I'm sure that happened a lot, but it doesn't happen very often anymore.
Yeah, it's been a good 20 years since we've had a good snowstorm sneak up on us. That 2000 storm,
the 2000 storm, that's infamous in the Raleigh, the Carolina crippler, right?
Right. And we haven't had one that was poorly forecast since then. It's just that we've gotten pretty good at this weather forecasting thing in recent years.
Yeah, most storms underperform here. They don't overperform.
Right. That's the king of overperforming storms there, that 2000 storm.
And normally it's the warm nose's fault, which if you want to see that's today's weather IQ on WCNC.com.
Yes. Yeah, as I was talking about the wedge today, that's all I thought about. I'm like, it's a miserable cold rain, but it's not ice.
Could be worse. Yes, you tweeted a picture today, which I feel like is every wedge day ever. But when people are trying to grasp what a wedge is, or what a CAD is, or what cold air damming is, I mean, 46 in Chester County and then 73 in Columbia. I'm just like, maybe I'll go south today and just drive.
And 81 in Charleston. It was 81.
Yeah, that's just, and our high happened around midnight. I mean, I woke up, it was 60 degrees almost outside, and then by noon it's like 44 degrees out. It was just, the CAD I love it. I mean, as I posted there, I mean, it's frustrating to forecast sometimes, the meteorologist, but I marvel at it. it's fascinating. It's something that the Carolinas, it does happen in other parts of the country, but nothing to the degree that it happens here. It is just, it's something that we own here in the Carolinas.
Right.
We should have T-shirts that say we survived the Carolina Cold Edge, because
I'm working on a new phrase called CAD crashing. Time for more coffee. I'm CAD crashing. 4:30 this afternoon.
That's the first thing we try to train our new Mets on. The first thing I tell them is go to the comment modules on cold air damming and study those religiously when you come to Charlotte, because you're going to have to learn that. And the thing is, the only way you learn to forecast it is by failing at the forecasting, because that's how you learn to forecast.
And then 20 years on, you're still failing at it sometimes.
Yeah. It's always going to come in stronger than you think, and it's going to hold on longer than you think. And
stubborn.
There's
Nothing
always
humbles a
surprise.
Carolina meteorologist like the wedge.
Yes, it is. I love it, though. It makes the job interesting.
Right.
That is true. Before we get too far away from your Verify, a couple comments from our loyal viewer, NCTN High Country Weather. Been following Brad for many years. His explanations on weather topics he gives, like no other, always great information. And I think that was what was so great about that story. It was the kind of the marriage between the station's weather IQ, making you smarter, and the Verify fact checking, where we took this weather myth and put them together.
Yeah, I love it. I think there's a lot of weather myths. We could have a whole Verify series on weather myths. There's so many of them that, just pop up over the years. And yeah.
Woolly worm. Let's see. What do we got?
Oh, my gosh.
Foggy mornings.
Oh, that's funny. That's a big mountain thing, is to count the number of, fogs in August. You keep beans in a jar. And there was a lot of fog this August in the mountains. I'm going to have to look at some of these jars, but there's only been like 2 snows, I would say, so far in the mountains. Last time I was up at Winterfest, we were talking about that. I think Beach Mountain had 5.5 inches before that Northwest Flow event gave them like 7 inches. So everybody's running way behind in the mountains. So it's been a weird year. My winter forecast was for warm and dry, and it's been warm, but it has not been dry. It's been
definitely not.
Amazing. Almost feels a little El Nino-ish, or like we're kind of transitioning here. And then you see the storms coming through California. I was in Tahoe with all the snow out there. That feels more like an El Nino pattern for the West Coast. So it's been a really interesting year. And I think it has a lot to do with the transition. We are kind of transitioning out of La Nina to a neutral phase. So something's going on with the subtropical jet, which is putting us in the storm track, but it's not far enough south to give us the cold air. So it's been an interesting winter. We'll see. It's still ways to go. As everyone in the Carolinas knows, late winter, early spring, you just gotta hold your bets on no snow, because we could still get one before this year's over.
Yeah, you mentioned your winter weather forecast, and I don't want to remind you, you called for 5 inches in Charlotte. So
yeah,
you still got time.
I need my one storm. I was counting on one good storm.
That's right.
Listen,
we need one.
Listen, I was up there with y'all. It was cold and wet up there, so we might have been out of our mind a little bit when we were doing that. It was
Although
it was snowing, we were happy.
It was.
Looking at long range, it is not looking good for a good snowstorm.
No,
come on, Frank, hold that
at all. I mean, we have almost nothing, no chance of anything anywhere for the next 2 weeks, and as we get toward the middle of the month, it looks like the P&A goes strongly negative again. If that happens, you can forget snowstorms down here.
We're going to need some sharp little cutoff trough or an upper low or something freaky to come along and give us a snow.
Right.
Or we all get in the car and drive up to the mountains where it is actually snowing. So if you're watching from the mountains and wondering what we're complaining about, yes, we acknowledge it is snowing this season in the mountains, just nowhere else.
Not enough, though. For the skiers, it's never enough.
Never enough. Well, Brad, thank you for coming on and giving us your insights here on the Carolina Weather Group this week. And folks can find you on WCNC television throughout the week. And as mentioned, but I'll say it again, you can catch those Weather IQ segments each week, helping you learn about the atmosphere and science around you. And then the station's got their Verify fact-finding brand too. So if you have a thing you want to learn about weather, or a thing you want debunked, or even just to find out whether or not it's true or false, you can tweet at Brad, WX Brad. Yep. I'm sure everyone watching and listening this week already knows that. And they'll take a look at it. Anything else, Brad? I would ask where people can follow you and where they can watch you, but I think that's pretty covered here with our loyal audience.
Yeah, I hope everyone knows where to find me. WX Brad, pretty much on any social media, and I'm still holding out hope for snow. I'm with Frank. I don't think the pattern looks great in the next 2 weeks, but I'm hoping we get some freak little thing. We only need thing to time out for one day, get us our one snow, and then we can move on to spring. So I'd like to see one more good event, maybe just a couple inches. I think 5 inches is wishing right now, but 2 or 3 inch snow would be great, something like that.
Well, there's plenty of history of late season snow in the Carolinas. I remember one when I was a kid on March 24th. So had 10 inches in Rock Hill from that storm.
Yeah, good. We'll get an active March. We could have one of those weird years where it's like colder and snowier in March than it was in January or February.
It could happen.
I've seen that happen before too. It's nuts.
Yeah, well, March of 60. Remember?
Oh yeah,
the
snowiest month all time in Charlotte. Yeah.
Right.
It snowed every Wednesday, right?
Mm-hmm.
Well, I think Scotty said it to me on the phone the other day. He goes, "You know what's going to snow in April when no one wants it anymore."
Yes.
That's right.
When we're ready to go golfing and we're trying to grow stuff, and they're like, "What's this snow? This should have been
What's this
January."
freeze? What is this?
Yeah.
Well, Brad, thank you again. We'll watch at 11 o'clock. At least I'm going to watch at 11 o'clock and find out when this maybe this CAD's going to give away. I can see the sun.
Yeah, if you remember what the sunshine looks like.
I have no idea.
I do. Yeah, it does. Hopefully, it'll be this weekend, but not. It's going to be freezing cold when it comes back.
That's fine.
Our day and a half Arctic outbreak this time.
Yeah. So, Brad, what do you think? I saw some of the models today were showing that that this rain Friday ending as some wet snow in some places along the Carolina.
I'm
what
not
do
a
you
big
think?
fan of cold air chasing moisture. That's a fool's errand. It happens 1 out of 10 times.
Yeah.
It's like.
That's
a
right.
little Anna front setup. I don't know about that. I think the mountains have a good chance for a nice little short, sweet northwest flow event as that Arctic front comes in. And that sets the stage for a good ski weekend in the mountains because the snowmakers will go crazy starting Friday into Saturday, and they'll replenish those slopes real quickly. So that's good news. I'm happy for the ski resorts because President's Day weekend is coming up in the middle of the month, and that's a huge ski weekend in the Southeast. So we got to get some snow laid down for those folks for that weekend.
Sorry, I had don't go chasing waterfalls stuck in my head the entire time you were talking.
Yeah.
Can't play it. I can't afford that.
No.
It's way too much money. So thank you, Brad. We'll catch you on WCNC Charlotte Television, WCNC app, and all places where you consume your news. Check for Brad Panovich and the WCNC Charlotte weather team. Before we go this week, we caught up with Steven Jaume, a College of Charleston professor who studies earthquakes because you know it. You don't need us to tell us. South Carolina just cannot cut a break with these earthquakes. Scotty picks up the conversation from here.
Steven, thank you so much for joining us. I know it's been a while since we've had you around, and we were talking here just off camera. It's been kind of busy for you lately.
Yeah, a little too busy, if anything. So what I'm having starting December 27th in 2021, I got to remember what year it is, up through December 10th of last year, 2022, we actually had 82 recorded earthquakes, or reported, I should say, and that they were big enough to be located on enough seismometers to actually formally get a location and magnitude. There's actually probably about 2 or 3 times that number you can see in the very closest seismometer, but don't have enough information to actually make a formal location. But that's kind of been the big deal in South Carolina, is an unexpected place, right? As far as I can tell, there's been no record of earthquakes there previously. Now, there was one, I'm looking on a map I have off to the side here. There was another one at the same time, just a little south of Camden. There have been earthquakes there before, so that was not the first one at that location, but that is physically separated a bit from the swarm. And this is kind of one of the longer running and somewhat more unusual swarms of earthquakes that we get in the East Coast. We don't typically get things like this very much on this side of the country. We're more likely to see these in volcanic regions where you have long swarms of earthquakes. They do happen other places. It's just that, as far as I know, the first time we've had in recorded history something like that here in South Carolina.
Yeah, Stephen, you mentioned that this kind of activity usually happens along volcanic zones, where the tectonic plates are conjoined, right? So what is the cause of this? I mean, we're not at a tectonic meeting here, right? No. We're not in a volcanic zone. So what kind of faults do we have going on?
The swarm of earthquakes falls within something called the Eastern Piedmont Fault Zone that roughly parallels the fault line. It starts down in Alabama, goes up to Virginia. Now, this is not a single fault. It's kind of a set of semi-parallel faults that run roughly along the fall line. And that's not what's moving. These are actually these ancient faults. There are what we call cross faults, little links between individual faults that run at an angle to the main faults. One of these has been moving, as best we can tell. And which actually, if you look at, so we in seismology, has anyone ever heard of something called a focal mechanism? No.
I can't remember. I took a class at CFC where you're at, and I remember some of these terms, but it's been a while. So
basically, it's a way of displaying the earthquake motion as recorded by a seismograph. And what it does, it tells you the orientation and the type of slip in a fault, right? And we've done these for earthquakes over the years throughout the Southeast. And roughly, it's sort of a north-northeast to east-northeast to west-southwest direction. You're squeezing the East Coast. So certain faults oriented at the proper angle to that force will move, other faults won't. The Eastern fault system, the main faults, are in the wrong orientation, but these cross faults in that system are in the right orientation. And that's what appears to be moving. So we've looked at the previous, we'll call them focal mechanisms for the Southeast. We look at the larger earthquakes and the Elgin swarm, look at its focal mechanisms. For those larger ones, they match the type of motion we expect in South Carolina. So on one hand, they're not unusual, right? In terms of what kind of, what orientation of fault is moving. I don't know if people remember the Valentine's Day fault back in 2014 near Edgefield, the earthquake. There's a magnitude 4 earthquake near, that's kind of in that same zone and just over closer to the border, almost to the border with Georgia. Same kind of focal mechanism that we're seeing in Elgin. So they're natural in that sense. It's just the location's unusual in that we've never seen an earthquake there before. Now, if we had 1,000-year record of earthquakes in South Carolina, maybe it wouldn't be unusual, right? It's just it's time to go. But there's nothing I've seen that says, oh, wait, something completely new is happening. This is not really completely new. It's the same old thing in a different place.
With us, meteorology, we have models that we look at to help forecast what's coming up. What is it like in earthquakes? Sometimes you hear people say, well, we're working on a way to get early detection. How is that work going? I mean, are we getting closer or?
Okay. I think you may be asking two different questions at once. Are you talking about something like the early warning systems out west?
Yeah. Like, I guess like, is there a way that people can start getting warning? I guess like an earthquake warning before something.
What they have out west, what they use, so you have an earthquake occurs. So it doesn't tell you an earthquake is about to occur. It tells you an earthquake has already occurred, but there are big waves coming to you. What it utilizes when the earthquake occurs, the fastest traveling energy we call the P wave is also generally the smallest. Right? So if you can detect those P waves and very quickly locate and estimate a magnitude of an earthquake, you can get warning to people at a certain distance from the earthquake that these slower but much larger S waves are on their way. And actually, believe it or not, they're using it now. It's called shake alerts, is what they have on the west coast of the United States. If you're right on top of the earthquake, you don't get any warning. You're just too close. Because it takes a few seconds for the automatic system to work, to actually locate it, put a magnitude on it, and say, oh, okay, this is one we have to warn people, at which point things have already traveled some distance. So you can only get so far ahead via the speed of light, the speed of electronic communication. But if you're a far enough distance away, you can get several seconds to several tens of seconds of warning, which, depending upon your situation, might be enough to take cover, might be enough, get out of some vulnerable situation. I think there are certain places, like the fire stations, that alert hits, the doors go up automatically. make sure the fire truck doesn't get trapped in the building, right? You can do certain, fairly automatic reactions, or you can react personally with those even seconds of warning. Again, it's not telling you there's going to be an earthquake. It's telling you one has already occurred, but the damaging waves haven't gotten to you yet, but they're on their way.
I've always wondered, and you see these bigger earthquakes happen maybe in the Pacific area, and some trigger tsunamis and some don't. Like, what facilitates that? Is it a certain magnitude that maybe facilitates, this area may see a tsunami, or we see these big earthquakes happen, and then you see when there's a tsunami expected, or a small one, or something like that. Could you kind of How does that work?
Well, where you get the big tsunamis is when you have what's called a subduction zone. So imagine this is part of the ocean crust. It's going down into the interior of the earth. And typically on the side above where it's going, there'll be a line of islands with volcanoes, right? The volcanoes themselves are tied to what's going on with this. I won't go into that detail. But this gets stuck. But it tries to go, it kind of bends things down. And when the earthquake occurs, it releases and that pops up. Now, there's a few miles of water above where it pops up. So suddenly you're standing this big pile of water up in the air. That's your tsunami.
Yeah, that makes sense.
So you need an earthquake along what's called a subduction interface, but the part where it's close to the ocean floor. If an earthquake occurs way down 200 miles deep in the earth, it won't cause a tsunami. If the earthquake on the ocean floor makes the ocean floor go sideways, it's not going to cause a tsunami. You've got to vertically uplift or drop down a big chunk of ocean floor, and at places called subduction zones. So we have the deep ocean trenches are adjacent to subduction zones. Those earthquakes are the ones that cause the big tsunamis.
And that was going to lead me to my next question was, which way would it be coming from most likely because I know it's not, although not very common or very rare, we're not immune to it along our coastline, but which direction would it be coming from, do you think?
Well, where are we talking? He was talking about the Pacific before.
I'm talking about the Atlantic on our side.
Okay,
our coast.
Yeah.
Yeah, come back to ours, like the Mid-Atlantic Rift, right? Because that's way out in the middle of the Atlantic.
The Mid-Atlantic Ridge is not a subduction zone, so that will not cause a tsunami. We have the Puerto Rico Trench to the south of us, right? Had a big earthquake of the kind they have out in the subduction zones out west, that will cause a tsunami. This is still kind of the details. I certainly don't know the details, but off the coast of Portugal, it appears a new subduction zone is just starting to form. There was a very large earthquake in 1755 off the coast of Portugal, sent a big tsunami on the coast of Europe, down to Africa. The tsunami showed up in the Caribbean, in the Leeward, Windward Islands. I forget which ones are which down there, even in Canada. For some reason, I can't find a record of it showing up on the East Coast, but there may be some other explanations for that. But we do have some fairly few, but some places in the Atlantic that have the subduction zones, and those can cause some.
So there you have it. If you live in South Carolina, you felt any of these 100-some earthquakes that have emanated largely out of Elgin, South Carolina. Hopefully you got a little bit of additional insight there as to why those may be occurring. Frank, have you felt some of those there in Columbia?
Two of them. I don't remember which day it was, but they both happened the same day. Both 3.6, if I remember correctly. Yeah, that day we did have a couple stronger ones as well. So we thank Steven Jaume of the College of Charleston, Scotty, and our own Shay Gibson for catching up with him. That's one of the many things that you can get early access to by becoming a fan and supporter of the Carolina Weather Group at patreon.com/Carolina Weather Group. You can get early access to select interviews, and you can do that and help keep the show on the air. We bought new lights with our Patreon money last year. So if you like our ugly mugs,
thank these fine folks scrolling at the bottom of your screen right now, patreon.com/Carolina Weather Group. Well, that does it for another live edition of the show. Scotty and Frank, it's always a pleasure to see you. So great to catch up with Brad. And fingers crossed it snows.
Yeah, I'm done. I'm over it. I'm ready for it to warm up.
It's February 1st. He's checked out already.
That's
folks.
right. December, January, bring it on. After that, let's get to warm weather.
Yeah. I'm always happy to get one good snowstorm each year, but I don't want it to happen in April.
Yeah.
Agreed. So now is the time. There's no day. There's no time like now.
That's true.
Yeah. Well, you never know. In South Carolina, it seems that mid-February is our favorite time to get big snowstorms. So we'll see what happens.
We'll see. We will leave you tonight with this live look over Columbia, courtesy of WeatherStem there at the University of South Carolina. Stay subscribed. We'll see you again real soon from the Carolina Weather Group.